Okay, good evening. Welcome to
Minute Math number 2.
Minute Math number 2. This is a series of problems from old high school math contests mostly, or some junior high contests, put out by the Mathematical Association of America. And I think they're such great examples for kids about fun and hard math problems. This one's kind of more hard than fun, but that's okay. That I thought that we're going to try to do some videos when we can. Okay? Are you ready?
Yep.
A coin is flipped 3 times and another is flipped 4 times. Both coins are fair.
What does fair coins mean?
Fair means 50% of the times you get heads, 50% of the times you get tails. Okay? So it's completely fair. So if you want to say, hey, I flip a coin and you get to stay up 15 minutes later, or if it's heads and go to bed 15 minutes early if it's tails, that'd be fair. Right?
Yeah.
Okay. What is the probability that both coins show the same number of heads? Okay, so one's flipped 3 times and another's flipped 4 times. So there's actually some pretty neat math here. So when you flip a coin 3 times, how many different values of heads can you get over the course of those 3 flips? You might get
Head. Well,
how many different ones might you get?
how many different combinations?
Just you flip one coin 3 times. What are the different number of possibilities for heads? You might get heads once out of 3 times, for example. But what are all the possibilities?
You get heads 0,
0,
1,
1,
2,
2,
and 3.
and 3. 0, 1, 2, and 3. And it turns out the number of ways to get heads 0 times is just one way. In other words, you have to get all tails. There's 3 ways to get heads once. On the first time, the second time, or the third time. 3 ways to get it twice. If you get 2 heads, you only get 1 tail, right? So you get that 1 tail occurs on the first one, the second one, and the third one. And there's only 1 way to get heads 3 times.
1, 3, 3, 1 is 11 cubed.
You're right. You're right.
That's funny.
1, 3, 3, 1 is 11 cubed. You're right. This is the 3 times. Here's the 4 times. Do you know where else 1, 3, 3, 1 shows up?
No.
Do you remember it from Pascal's triangle?
Oh yeah, that's like the third row.
1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay. When you flip a coin 4 times, there's 1 way to get 0 heads. 4 ways to get 1 head. 1 first, second, third, fourth. 6 ways to get 2 heads, and 4 ways to get 3 heads. There's also 1 way to get 4 heads, but you can't get 4 heads with 3 coins. Right?
Yeah.
3 flips, so this doesn't count. Now, how many total different possibilities can you get flipping 1 coin 3 times? Well, I'll ask it and answer it. Each time you flip it, you have 2 possible things you can get, heads or tails.
Yeah.
So you get 2 to the 3rd ways. And 2 to the 3rd is?
8.
So this is 1/8, 3/8, 3/8, and 1/8. This is 1/16. There's 2 to the 4th ways you can get 4/16, 6/16, and 4/16. Right now I'm not simplifying the fractions. So the probability that you've got 0 both times is 1/8 times 1/16. You know what 8 times 16 is? You can probably figure that out pretty quickly.
80 plus 8 times 6 is 48.
48. Notice we're going to have 8 times 16 on the bottom of our fraction every time. So here's 1. 3 times 4 is?
3 times 4 is 12.
12. 3 times 6 is?
Is 18.
18. 1 times 4 is?
4.
4. Okay, there you go. So what's 1 plus 12 plus 18 plus 4?
Well, 12 plus 18 is 30.
That's right.
So it's 35.
35. There you go. 35 1/28 is the answer. It's a pretty neat problem. So if you flip a coin, 1 coin 3 times and another coin 4 times, the probability that they both have the same number of heads is 35 1/28, which is a little bit less than a third. A little bit, tiny little bit less than a third. Pretty neat.
Yep.
Think you'll ever be able to do a problem like this?
Maybe.
Pretty soon. But this is a tough problem for an 8-year-old. But I wanted to show it to you because it's pretty neat. Good job. Good job.